This topic is called inverse functions or relations. Now, what's an inverse relation? It's a relation or a function where you switch the domain and the range values. The notation almost looks like an exponent, right? We have this right here as the notation. However, we pronounce it as f inverse of x. Okay, don't call that f to the negative 1 of x. That's f inverse of x. Now, what are the properties of inverses? How do you know that f and g, the function f of x and the function g of x, are inverses? Well, if you have f of a equal to b for function f, but for g, if you had g of b equals a. Now that's kind of confusing, but let's go ahead and give you an example. Let's let f of x equal x squared, and let's let g of x equal the square root of x. We should know by now in our math careers that those are inverses, but let's go ahead and prove it. Let's go ahead and find f of 3. Well, f of 3 means take 3 and plug it in here. That's 3 squared is 9. So that's saying f of 3 is equal to 9. This is saying that I should be able to plug 9 into my inverse function and get 3. And let's see, is that true? If I do g of 9, do I get 3? Well, what's the square root of 9? Well, that is 3. So in other words, an inverse function undoes itself. When this one goes from 3 to 9, this one goes from 9 to 3. It's like the opposite direction, right? And that kind of makes sense when we look up here again, where the domain and range are switched. Here, this is my domain, and this would be my range. But in this case, my domain is actually the 9, where it was the range over here, and then my output or my range is 3, whereas my domain was 3 over here. So the domain and the range are switched. What do we also find? We also find that f of g of x is equal to x. In other words, they cancel out. So let's see if that's true using these functions right here. What is f of g of x? Well, remember my g of x in this case is square root of x. So that's the f of the square root of x. Plug the square root of x into here. So that's going to give me the square root of x squared, which does give me x. Similarly, g of f of x, so I'm going to have g of x squared. I'm going to go ahead and put x squared into here. So that's going to be the square root of an x squared. Okay, and that's going to give me just plain old x. So you can see that these functions undo each other. They are inverses. Their domain and range are opposites. What are the steps for finding inverses? Well, the first step is going to be just to replace f of x with y. The second step is going to be to switch or interchange your x and y. And your third step is just going to be to solve for y and to replace it with f inverse of x. So let's actually try that with the functions that we were talking about. Let's find the inverse of f of x equals x squared. Well, this says to replace my f of x with y. So I get y equals x squared. And then it says to change your x and your y. So I'm going to get actually x equals y squared. And then solve for y. So I'm going to square root both sides. It's going to give me y equals the square root of x. It actually gives me plus or minus the square root of x, so we found 2 inverses. And then we're going to go ahead and take that y and replace it with f inverse of x. We've just proven that the inverse of x squared is a square root of x, specifically plus or minus square root of x. All right. Oop, I got more here apparently. Now, when you're graphing inverses, it's kind of cool because they end up being reflections over the y-axis, not the y-axis, the line y equals x. So if you were to reflect this here, you would actually get this exact thing right here. And if you don't believe me, this thing right here would have reflected to this. Kind of see that symmetry, and then this one here would have flipped over to have been that. All right, oopsie. Let's go ahead and practice finding an inverse because that's going to be the most important thing on your test or your quiz. So I'm going to go ahead, I'm going to take that f of x and I'm going to replace it with a y. Then my next step is going to be to switch the x's and the y's. So this is going to be an x equals -1/2 y plus 1. My last step is going to be to solve for y. Well, to do that, we got to get y all by itself. I'll subtract 1. So this gives me x minus 1 equals a -1/2 y. Now, how do you get rid of -1/2? Well, you're going to multiply by -2 on both sides. Don't forget your parentheses. So I'm left with a -2 x minus 1 equals, well, the -2 and the 2 cancel, and you've got your negative canceling, so you're just left with y. And if you want, you can leave it like that, or you could go ahead and have that as -2x plus 2 equals y. And then remember, we replace our y with f inverse of x being equal to -2x plus 2. So folks, all I've done is rewrite the problem with a y instead of f of x, switch my x's and my y's, and then solve for y. All right, here's another problem. Instead of g of x, we're going to write y equals x minus 4 over 2. Switch my x's and my y's, so I get x equals y minus 4 over 2. In this case, I'm going to multiply by 2 on both sides. 2's cancel, and I'm left with a 2x is equal to y minus 4. Add 4. Minus 4 and 4 cancel, and I'm left with 2x plus 4 is equal to y. Last step is to rewrite this as f inverse of x equals 2x plus 4. All right, let's do 2 more of these. They're getting a little more challenging. We've got square roots and exponents. So again, here we rewrite this as y equals square root of x minus 2. I switch my x's and my y's. Now in this case, how do you get rid of a square root? Well, you square it. So I'm going to square this side. I'm going to square this side. That's going to give me an x squared equals y minus 2. Add 2 to both sides. And I get x squared plus 2 equals y. All right, last algebraic example, and then I want to look at some graphs. So here I'm going to rewrite this as y equals x squared minus 4. Switch the x's and the y's. Okay, getting y all by itself, I add 4 to both sides. Here I get x plus 4 equals y squared. Square rooting both sides, I do get a plus or minus the square root of x plus 4 equals y. And then rewriting that, we get f inverse of x equals plus or minus square root of x plus 4. And I should have rewritten this one as a f inverse of x as well. I wouldn't mark it wrong though. All right, let's just finish up by looking at some graphs. If I said find the inverse of the graph function below, I mentioned this earlier, but remember, if I asked you for the inverse, you're switching the domain and the range. So my f inverse of x function is actually going to switch these two things. So here it was x and y, and then here we're actually going to have the x and the y swapped, as we know from our pattern. So this will be a 4, -2. This will be a 1, -1. This will be a 0, 0, 1, 1, 4, 2. See how I said instead of a 2, 4, I'm doing 4, 2. All right, graphing these. Let's go ahead and do that really quickly. I get this, which is exactly what we would expect. We just talked about how that's a reflection over the line y equals x, which makes total sense. You're letting your y be x and your x be y. And the other thing that makes this make sense is we've actually already found the inverse of x squared. Remember, we got the square root of x, and then this one right here was actually the negative square root of x. So we have confirmed that multiple times. So a couple takeaways from this: if I gave you a table and said graph the inverse, you just flip the coordinates. The other takeaway is that inverses are always reflected over the line y equals x. And I guess the third takeaway is the fact that you can always switch your x's and y's and solve for your inverse, and that's how we got this